This topic you're trying to guess. Now, I don't know whether I'll be able to give you today's topic properly or not. I'm trying. I'm trying my best. Okay. So all of you here, those who have gathered on this platform,
100%
are all students who have cleared the entrance test for Bhavishika. You all know we have. Please, please mute yourselves. I don't have to repeat every now and then, so please mute yourselves, good children. Okay. Now we all know that you have gathered here because you have cleared the first entrance test, and all of you are going to be involved in making a satellite which will fly into space in 2024 or 2025. And I'm sure all of you are excited. So we are going to have one more round of the entrance test, which will begin on 21st, 5th of April. So these are 4 introductory lectures that we will be having, in which we will be doing some different topics for you, which will make you interested in exactly what we are going to do after the 1st of May. Okay. So I'll start sharing my screen. It is exactly 5:30. And after I start sharing the screen, after some time, you will come to know what is today's topic. Okay. Now, all of you know that for Bhavishika, we have a tagline. You know what is a tagline? The tagline for Bhavishika is, okay, how many of you have seen Nike products? Nike product says, just do it, isn't it? What is the tagline for what you can say? Now, give me one example for a tagline. Your school has a tagline. Yes. So the tagline for Bhavishika is Asman ko chune ki asha. What is our tagline? Asman ko chune ki asha. So all of you are now going to move towards space. So today's lecture that we are going to have, it is going to be divided into 3 parts. In the first part, I will be explaining to you, or I tried to tell you, what exactly is the meaning of the word cosmology and what is cosmology, where it is helping us, how do we go about it? Okay, so here we begin. I'm sharing my screen, and allow me to settle in a minute so that I can show you the screen properly. And okay, slideshow. Mr. Santosh, can we see the slides properly? Is there any issue? So Bhavishika 2024, time is 5:30 past. We are beginning with our first lecture. Okay. What is cosmology? It is the study of the universe, its structure, origin, evolution, and destiny. So the study of the universe, which is cosmology, in which we study the structure, the origin, evolution, and destiny, our universal worldview, and our cosmological model. Okay, so we now start moving towards the journey of what is the study of universe. Now, every one of us, I remember when I was in school, I always used to wonder, how did this universe ever form? When did it form? How did it form? So these are questions which are in our minds for years together. So the study of cosmology helps us to make this study a little easier. So our view of cosmology. Now, astronomy has seen three scientific revolutions. Three scientific revolutions in cosmology. Please mute yourselves, all of you. Once again, last warning. Okay. Second century, if you see the second century, it was the physics of Aristotle. Claudius Ptolemy, during that time, said the universe is, the model of the universe is earth-centered. So earth-centered. So what was the big idea? The big idea is different laws for earth and the cosmos. That means earth had its own laws and cosmos has had its own laws. So it was called earth-centered cosmology. It was physics of Aristotle. This was during the second century. Now comes the 16th century. And you know what Newton did, isn't it, during the century? Newton sat below an apple tree, and instead of eating the apple, he gave you a theory. And all of you have to study his theory, his laws. So during this time, Nicholas Copernicus suggested that the universe, the cosmology that we talk about, is sun-centered. That means earth-centered was not correct. So he said the sun is in the center and all the planets move around it. Big idea was universal physics and same laws are everywhere. So the earth doesn't have different laws and cosmos doesn't have different laws. All laws are same for the universe. Then came the 20th century and we know the very, very famous scientist Einstein. His theory of relativity was a revolutionary theory which made a lot of changes in the different parts of physics that we know of. And during this time, Edwin Hubble proposed a model of Big Bang cosmology, the Big Bang theory. And the big idea in this was universe is changing and universe is evolving. So I'm quite sure you have understood what we are going to talk about today. We are going to talk about the physics of Einstein, that is the Big Bang theory, what exactly it is, and what should we know about it. So going on, the next one, why was the earth as a center? Because this model that earth is the center and all the other things revolve around the earth, it was successful for 1500 years. So 1500 years thought that, or people thought that, I do not want anyone to disturb me in the middle. Please do not ask for sharing the screen. Please don't disturb. Otherwise, these students, I'll be forced to remove them from the class. Okay? So sit quietly and listen. I don't want any one of you to now chat with me. Okay? So the earth-centered theory, which was successful for 1500 years, was proved to be wrong. And then came the sun-centered cosmology. So everything is at rest sorry, the sun is in the center. In the middle of everything is the sun. And this was used by Nicholas Copernicus. Now, what is the testing theory? What was tested in this? The prediction was sun is at the center. Observation was sun is not at center of universe. That was in 1980. And the observation, the galaxy is not the entire universe. At that time, we knew that we belong to the galaxy, and this galaxy is not the entire universe. That means the universe is beyond our galaxy.
पुष्कर
This was observed in
येथे सुरू झालं
1993. Please mute yourselves. Then came the Big Bang cosmology. And what was proposed? A human being is a part of a whole called by us universe. It is a part limited in time and space. And this was by Einstein. So the Big Bang cosmology was proposed in the beginning of the last century. Testing it. Now, if it was tested, what was the prediction? The universe is expanding. That means the universe is moving. Galaxies are moving apart from each other. And this was proposed in 1929, that all the galaxies that are present in the universe, they are moving away from each other. And the universe ever expanding. So slowly we are going to understand exactly what is happening in the universe. And this is something which intrigued everyone in this world. Everyone wanted to know what is happening in the universe. So how do we test the Big Bang? The prediction was a hot, dense, expand universe should be predominantly hydrogen and helium. Now, these two heroes of our chemical industry, who are these two big heroes? Hydrogen and helium. These are the part of the dense expanding universe. So, those who know the periodic table know that hydrogen and helium are way above the others. One in the left-hand corner and one in the right-hand corner.
आई तू
आईला शांतपणे बसून द्या घरात. Observation, universe is 75% hydrogen and 25% helium by mass. Again and again, I'm saying, please mute yourself. All those who are sitting in front of the camera, it is almost 1 year that we are using online modes of learning, listening, studying, and every one of you knows how to mute yourself. So a sincere appeal, a sincere request to everyone, please mute yourselves. So the testing began and we all knew that universe is 75% hydrogen and 25% helium. Now, if you can see, there is a name given there, Cecilia Payne. In 1925, she proposed that the universe contains 74.89% of hydrogen and the rest 24.75% of helium by mass. So the testing for the Big Bang theory began, and slowly we understood that the Big Bang theory may be right. So many theories before that were also proposed, but many of them could not be tested properly, and also we were not in a position to accept them. So what were the conclusions? The conclusion was the Big Bang model describes our current understanding of the universe. So the Big Bang model is what we are going to study today. New discoveries such as dark matter and accelerating expansion, dark energy, that is accelerating expansion, lead us to refine our model. But there is no crisis in our understanding, of course, yet. And all of you, those who are sitting, listening, watching, thinking, and logically reasoning out, maybe one of you might try to find out that there is a crisis in the Big Bang theory also. We don't know. You may be bright enough to understand. Now, if you really go back, during the time, 2nd century, 16th century, what was available to the scientists, to the astronomers, to the cosmologists? There was no Google Baba, there was no internet. We did not have so many technological devices with us. But these people who proposed these theories had an excellent brain. And all of us know that in our brain we have neurons. And all these neurons work with electrical impulses. So their electrical impulses were so strong that they proposed such wonderful theories. So children, those who are listening today, if you start really working hard on these, maybe a day might come when you can challenge the Big Bang theory also. So that is why I have written here, but there is no crisis in our understanding, and in brackets I put yet. So let's hope this yet remains as yet. So science is an ongoing process. It forces us to test our model through prediction and observation. Now, if we have to prove anything, if any process has to be done, if any theory has to be proved, first of all, we predict, then we observe, then we conclude. And if there are more tests, we have more tests. And then when these tests actually are done and are successful, then our confidence in it grows. So the conclusions were the Big Bang model describes our understanding of the universe. Now the future of cosmology. What powered the Big Bang? What is dark energy? How did the universe begin? So today's topic will be, how did the universe begin and what happened during this time, and what is the Big Bang theory and what are we today because of the Big Bang theory. So children, okay, tighten your seat belts now because you are going to fly in space. So let's be ready to understand what exactly is Big Bang. Now, for those who can understand this, if you see in the universe, dark energy is 73%, dark matter is 23%, matter is only 4%. You, I, sun, stars, everything 4% in this universe. So we come to formation of the universe. Big Bang theory. Yes, there is a series where we have, it is called Big Bang theory, and many of you might be watching this TV show also. We are not talking about the TV show. We are talking about the actual Big Bang that happened. Now, I'm going to read this out to you. So just listen. In the very beginning, there was a void, a curious for vacuum, nothingness, containing no space, no time, no matter, no light, no sun. This was long, long ago. Yet, the laws of nature were in place, and this curious vacuum held a lot of potential. A story logically begins at the beginning. This story is about the universe, and unfortunately, there are no data for the beginnings. None. Zero. We don't know anything about the universe until it reaches the mature age of a billion of a trillionth of a second. A billion of a trillionth of a second. Imagine. That is some very short time after creation in the Big Bang. When you read or hear anything about the birth of the universe, someone is making it up. We are in the realm philosophy. Only God knows what happened at the very beginning. Now, this was said by Leon Lederman. He was a Nobel Prize winner of physics, 1988. And actually, people talk about God particle, and he is the one who proposed a theory also, what is the God particle. He got a Nobel Prize. Okay. Now, the Big Bang Theory. So today's topic is going to be, what is the Big Bang Theory? What are we supposed to know about it? Okay. It may explain how the universe formed, because we also want to know how the universe was formed. We have heard about from many people, but we have to understand. Again, I'm telling all of you to mute yourselves. Otherwise, I'll have to force Mr. Santosh. I'll make him the co-host, and then I'll have to ask you to leave. Please mute yourselves. Okay, so the beginning of the Big Bang Theory, it says, theory states that the universe began to expand with the explosion of concentrated matter and energy. With the explosion of concentrated matter. Mr. Santosh, are you there? There's too much of disturbance and noise. I don't know from where. So I think I'll have to remove those children who do not mute themselves. If I disable the chat, you will not be able to ask any queries. So I'm going to take time and see that everyone is muted, and I will not allow any one of you to unmute yourself. Mr. Santosh, I'm making you the co-host.
Okay, ma'am.
So if anyone talks, please mute them, or if they don't listen, we'll have to ask them to leave. Because
and one moment, ma'am.
Yes.
मैं कुछ बात करना चाहता हूँ सभी पार्टिसिपेंट से. अभी मैम आपको इतनी अच्छी तरह से एक्सप्लेन कर रही है, तो आप प्लीज डिस्टर्ब मत कीजिए, चैट बॉक्स को यूज मत कीजिए. अभी कुछ अगर इम्पोर्टेंट है तो ही चैट बॉक्स यूज कीजिए, वो भी बहुत इंपॉर्टेंट है क्वेश्चन पूछना तो. और एक दूसरे के साथ में डिस्कस मत कीजिए कोई भी चीज, ठीक है? थैंक यू मैम.
Okay, fine. So may I continue now? Good. Okay. So we were here. Now, exactly what is this and from where did the universe originate? Now, for this, we have to understand a new word. In 1920, it was first proposed. The Big Bang theory was first proposed in 1920. It states that there was an infinitely small, infinitely dense point that contained everything that is the universe. And this small and very, very small point was called singularity. So what you see here, the word singularity, this is the word. So this point, singularity, is where we began with our universe. So what happened with this singularity? But before we go to exactly what happened, in the late 1920s, a Belgian astronomer and a Jesuit priest, he was known as the father of the Big Bang. He first suggested that the universe formed from a singularity, but he had no evidence at all. Because at that time, we were talking about God made the universe. Of course, God made the universe. But from where did he make it? He made it from a single small, infinitely small particle, and that was called as singularity. So this was Georges Henry Lemaître. Then the Big Bang theory, which was proposed, says it is believed to have occurred between 10 to 15 billion years ago. Billion means there are 9 zeros. Most scientists agree that the universe is 13.7 billion years old. So most of them say the universe was born between 13.7 to 13.8 billion years ago. Two elements, hydrogen and helium, were created in the primordial fireball, along with small amounts of lithium and beryllium. Now, in 1929, you remember I told you in 1925, Cecilia Payne, she had said that the universe contains 75% hydrogen and 25% helium. Now, in 1929, Edwin Hubble studied the light given off by galaxies. He noticed that light from most galaxies was shifted to the red end of the electromagnetic spectrum. The second point which I'm talking about, when we go deeper into understanding of your physics, you will know what is electromagnetic spectrum. So he proposed Hubble's law after he studied these galaxies. So let us go back. There were three theories, there were three models that were proposed for cosmology. First was Earth-centric, Aristotle, then came Newton, became sun-centric, and then came Einstein, which is said is the Big Bang. And in the Big Bang, the father of the Big Bang theory was a priest, and he proposed that the universe was born from a very, very small, very, very minutely, infinitely minute small particle, which was called as singularity, but he did not have any evidence to put forth. Then in 1929, Hubble. Now we all know a telescope is also named after Hubble. We have a Hubble telescope. So he is one of the very well-known names in cosmology. He proposed Hubble's law after studying these galaxies. Now, what does Hubble's law say? It says, now see, understand this well. That is why we are saying that we are in a state of expansion. That means the universe is expanding and expanding and expanding. So he says the rate at which a galaxy is moving is directly proportional to the distance from us. So if the galaxy is moving, it is directly proportional to its distance from us. More the distance, Mr. Santosh, please ask this child to leave if we keep on doing like this. It disturbs. So the ever expanding galaxy is what we are now understanding. In other words, the farther away a galaxy is, us, the faster it travels away from us. Thus, what we say is the universe is expanding. So now we come to a very important theory which says that the universe is expanding, it is moving into and further away from us, and a day will come when it will be moving so fast. So end of the lesson, end of the session, I'm going to tell you what may happen after this. Now, we have to prove this theory. Which theory? We have to prove the theory that it is a Big Bang. And how do you prove this? So cosmic microwave background radiations was studied. Long wavelength radiation that fills all space. We know that. This can be detected using special antenna. Now, all of you know that you have a TV set and then you have an antenna in the TV set, isn't it? That is kept on the terrace of your building or your bungalow or your house. This antenna, what does it do? It catches the waves, the radiations which are coming towards it. And that is how you can see what is happening on the TV. So 1% of this can be detected in the static on your TV set. So cosmic microwave background radiation. And who predicted this? George Gamow in 1940 predicted. Now see, what is he thinking? He is saying if there was a Big Bang and there was an explosion, then we should be able to hear the echo of this Big Bang. Imagine what he is thinking. If a Big Bang happened, I don't think so any one of us can even imagine what the sound might have been. So George Gamow said that if the Big Bang happened and if the universe is closed, we should be able to hear the echo of this Big Bang. So people started thinking in different ways and different directions. So we began of the study of the Big Bang with cosmic microwave background radiation. Now, how was this done? And why was this done? There is a very mysterious sound which was coming. Penzias and Wilson in 1965, they were radio astronomers. And you have heard about Graham Bell. So Graham Bell at that time in America had already formed his Bell Telephone Laboratory. And these two astronomers were working with him in the Bell Telephone Laboratories. Now, what they found, a mysterious microwave signal was causing background noise in their radio telescope. Now you can see that on the screen, there is a radio telescope which is kept on the ground. And when they were studying these waves, they heard some mysterious sounds, some signals. And they said the signal is coming from everywhere. So where this must be coming from? Obviously, this is coming from the universe, from the space. That triggered the idea that yes, we can study what happened during the Big Bang. So what are the names? Arno Penzias and Robert Wilson. These two astronomers heard some mysterious signals, and then began the probe. Cosmic Background Explorer, called as the COBE probe. It was called the COBE probe. It looked 15 billion light years in space to find out if any tiny temperature has changed. We all know what is light year. Huge distances are measured in light years. And we know that light travels at the speed of 3 into dash 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 meters per second. You all know this, isn't it? And the time taken for light to travel in 1 year, you can understand how many millions and billions of kilometers it is. So the probe was to find 15 billion light years. Is there any change in temperature? And these temperature changes were evidence of the heat which was left over from the Big Bang. So the COBE probe began in 1989. 1989, I was teaching. So I was a teacher in 1989. You were not even born, all of you. So during this time, the probe began and a lot of study went on for the Big Bang theory. The next probe was WMAP. It is called Wilkinson Microwave Anisotropy Probe. WMAP captured the glow of the Big Bang by detecting temperature changes just like COBE. Imagine what the scientists think. See where their brain works, how they try to imagine and predict what must have happened so many billions of years ago. So the two probes that were moving towards the testing of the Big Bang theory was the COBE probe and the WMAP probe, which showed that yes, Big Bang happened. The Big Bang theory is somewhere standing on its own, proudly saying, I am correct, I am right. So the Big Bang theory begins here now. So in 1965, Penzias and Wilson, they heard some mysterious waves and sounds. In 1989, 1992, the COBE probe began. Then till 2001, the WMAP also found out that there is heat which was produced during the Big Bang. And here comes our theory now. Oh my God, this is a screen where lots of things are mentioned, but we are going to go into details of each of these. If I begin from the left hand, you can see there are 3 columns. The left-hand column right on the top is yellowish, then it becomes orange, then it becomes a little darker orange, then it becomes lighter and then whiter and then blue. These are the different stages of the formation of the universe. So what is yellow? Now we are actually going to understand what is magnitude. What is small, what is very, very small, what is infinitely small. So we are going to understand that now. So are we ready? Mr. Santosh, are we ready to understand now what's going to happen? Now, 10 raised to minus 43 seconds Planck time. Now, this whole chart I'm going to explain to you one by one. Okay? So, universe. A hot and infinitely dense point only a few millimeters wide was called as singularity. This singularity violently exploded. It is from this bang. Now understand, it is from this bang energy, matter, space, and time. Yes, time were created. Till that, there was no time, there was no matter, and there was no space. It was just a very, very, very tiny speck that was singularity. This singularity violently exploded. And this is what the bang was. And when the bang happened, what came out was energy, matter, space, and time. This was created. Nobody gets the control of my screen, my dears. Please don't ask me. Okay. Now, really tighten your seatbelts because Chaitanya, Kankanwadi, I am not going to give you the remote control of my screen. So please don't ask. So during the first 10 raised to minus 43 seconds after the Big Bang. Oh my, 10 raised to minus 43 seconds. That means 1 upon 10. And how many zeros? 43 zeros. Now, when I'm talking, 1 and 2 seconds are over. Can you imagine what must be the small time? So 10 raised to minus 43 seconds after the Big Bang, we have no theories because the known laws of physics do not apply only at that time. So in the beginning, the universe was most likely which had infinite mass density and zero space-time curvature. The size of the universe by the time 10 raised to minus 43 was probably less than 10 raised to minus 52 meters. You can imagine how very, very small it was. Before fundamental forces called as strong nuclear force, electromagnetic force, weak nuclear force, and gravity were all unified into one force. And the temperature was probably 10 raised to 40 Kelvin. Huge temperature. This is the beginning of the Big Bang. Time 10 raised to minus 43 seconds. The size 10 raised to minus 52 meters. And the most important 4 fundamental forces of nature, that is strong nuclear force, weak nuclear force, electromagnetic force, and gravity force, were all unified as one at this junction. Then what happened? What happened now? 2 eras emerged. 2 eras. After the Big Bang, 2 eras came. That means 2 space-time came. The radiation era and second, the matter era. So radiation era, the name only tells you that there was a lot of radiations given out during this time. And matter era tells you matter was formed. That was the beginning of you and I and everything on this world, in this world. These eras mark the key events that made up the universe. So Big Bang, time 10 raised to minus 43 seconds. The length or what it was 10 raised to minus 52 meters. And when this Big Bang happened, After that, two eras were there, radiation era and the matter era. Now, let us see what is this radiation era. Now, all of you, please mute yourselves. Parents, if you are sitting with your children, please understand we are on a common platform. This is not done. Mr. Santosh, please mute these people or ask them to leave them if they don't listen. Now, this radiation era is broken up into small epochs. They are called epochs. EPOCHS. You know what is an era? Era, it is a time period. We all say Shivaji ka era. We all say Mughal ka era. We all say British era. That is the time. So radiation era happened after the Big Bang. That was the first era. It was divided into 8 parts. It is made up of 8 small epochs. First was Planck. Second was Grand Unified. Third was Inflationary. Electroweak. Then Quark. Then Hadron. Then Lepton. And Nuclear. Oh my God, you have to remember these 8. Planck era, Planck epoch, Grand Unified, Inflationary epoch, Electroweak, Quark, Hadron, Lepton, Nuclear. So let us see now each epoch how it is. Now the first one was Planck epoch. No matter existed in the universe at this time. No matter existed in the universe at this time. What was the time? 10 raised to minus 43 seconds. Temperature was 10 raised to 40 Kelvin. Time immediately after the Big Bang. What existed? Only energy. And which were the forces? Gravity, strong nuclear force, weak nuclear force, and electromagnetic force. Now, these 4 forces are the universal forces in nature. They all stay together with nice bhaichara with each other. But during this Planck epochs, gravity split away from the super force. These forces were called the super forces. So there were 4 super forces during the Planck epochs. Gravity, strong nuclear, weak nuclear, and electromagnetic. Out of that, gravity said, I am moving out because I have more important work to do. So the strong nuclear, weak nuclear, and electromagnetic force stayed together for the next epochs. The next epochs now is the grand unification epochs. See, the time is now decreasing. It is 10 raised to minus 41 seconds after the Big Bang. Temperature from 10 raised to 40 has now become 10 raised to 36 Kelvin. Yet too hot. Forces of nature, you remember I had told you gravitational force has already broken away from here. And the 3 forces, strong nuclear, weak nuclear, and electromagnetic forces were together in this 10 raised to minus 41 seconds. It is a split of a second. And during this time, the strong nuclear force broke away. So the second breakdown happened. The first breakdown was gravitational force. Second breakdown was the strong nuclear force broke away from the other 2 forces. Then came the third inflationary epochs. Time now 10 raised to minus 36 seconds after the Big Bang. Temperature 10 raised to 33 Kelvin, yet too hot. It started expanding from the size of an atom to the size of a grapefruit. Who started expanding? That small miniature singularity started expanding. So from the small atom, it gave the size of a big grapefruit. It was at this instant, it churned with electrons, quarks, and antiquarks. So three new words now you know, that electrons, quarks, and antiquarks. So those who have studied the atomic structure know that we have electrons, protons, and neutrons. So who was born first? Electrons were born first, and they had quarks and antiquarks. So it was in the third epoch that electrons, quarks, and antiquarks were born. Okay. Then came the fourth electroweak epoch. Electroweak epoch. Remember now, the strong and gravity, these two forces have gone away. They have split up. They have split up. The weak nuclear force epoch began at 10 raised to minus 32 seconds after the Big Bang. Temperature is reducing now. See, from 10 raised to 40, it has come to 10 raised to 20 Kelvin. And now the weak nuclear and electromagnetic also split off. So at this stage, all the four forces have broken off and have become independent. They are not together now. So the force of gravity, the force of a strong nuclear force, weak electronuclear force, and the electromagnetic force has now split off at 10 raised to minus 32 seconds at a temperature of 10 raised to 20 Kelvin. Then comes the fifth, the quark epochs. See, the time has reduced now. 10 raised to minus 12 seconds after the Big Bang. Temperature 10 raised to 16 Kelvin. And it was yet too hot and dense for subatomic particles to form. Now, which are the subatomic particles so far we have learned? Electrons, quarks, and antiquarks. So yet it is very hot. They are not allowed to come too close to each other. Electrons, quarks, antiquarks can't come together because the temperature is yet 10 raised to 16 Kelvin. High temperature. So at the quark epochs, by this time, all the forces have split up. Each has become independent. Who is independent now? Gravitational force, strong nuclear force, weak nuclear force, and electromagnetic force. These are all now independent at this time. So at 10 raised to minus 12 seconds, they are yet waiting for things to cool down. And it was yet too hot and dense for the subatomic particles to form matter. Then comes the sixth hadron epochs. Now see, time is 10 raised to minus 6 seconds after the Big Bang. Temperature now from 10 raised to 16 has come down to 10 raised to 12 Kelvin. Now it is cooling down at 10 raised to 12 Kelvin. So 10 and 12 zeros. So many degrees Kelvin is the temperature, and we are saying it is cooled down considerably. Now the quarks could bind into protons and neutrons. Oh my God, now it is the birth of protons and neutrons. So the quarks combined to form protons and neutrons. So what had happened? Electrons, quarks, and antiquarks were formed, and one epoch later, protons and neutrons could be formed with these quarks. Now we come to know how our atoms were formed, how matter was formed. Then comes the lepton epochs and the nuclear epochs. Time now is 1 second only after the Big Bang. Imagine 1 second after the Big Bang. Temperature is 10 raised to 10 Kelvin. And the next epoch is nuclear. 100 seconds after the Big Bang, temperature is 10 raised to 9 Kelvin. So what has happened now in this radiation era? The era is ending now. Why? Because matter has started forming. So in this radiation era, we have seen that there are 8 epochs. And what we have seen during this era is from 10 raised to minus 43 seconds to 100 seconds. What has happened? Gravity force moved away. Strong nuclear force moved away. Weak nuclear force moved away. Electromagnetic force moved away. Quarks combined to form the protons and neutrons, and the radiation era now ended at 100 seconds after the Big Bang. And from 10 raised to 40 Kelvin, the temperature became 10 raised to 9 Kelvin, cooling down. Oh, the universe is cooling down. Now, during this, the protons and neutrons underwent a significant change. And the first element in nature was formed, that is helium. The radiant era ended here, and matter was formed in the universe. So the radiation era gave us matter. And that is why we say that singularity was the God particle. God knows who made it, but there was a God particle through which the Big Bang happened, the first era of radiation, which lasted only for 100 seconds. And in these 100 seconds, atoms were formed. And the first element in nature, helium, was formed. So the radiation era ended here. All the chemical elements then started queuing up because we are now going to enter the matter era. The matter era had 3 epochs: atomic, galactic, and stellar. So we are entering the matter era. Now, I remember when we were in college, our professors used to tell us some nice jokes. So they told us that there were 2 people. One was a physicist and one was a psychologist. So the psychologist asked the physicist, "What is matter?" So the physicist answered, "Never mind." And he asked the psychologist, "What is mind?" So the psychologist answered, "No matter." So matter and mind, oh my God, how do we ever define? And now we know that the matter era has started 100 seconds after the Big Bang theory. Okay? The 3 epochs is the atomic, the galactic, and the stellar. So the previous radiation had 8 epochs. Here we have 3. Atomic epoch was about 500 million years after the Big Bang. Temperature was only 3000 degrees. And the first time electrons attached to the nucleons. Nucleons are nothing but protons and neutrons together, which form the nucleus of an atom. So during this time, what happened? The electrons went moving around the nucleons, and the element hydrogen was born. So helium was born first, and then hydrogen was born second. So the second element in nature was born. And this was the atomic epochs because the atomic structure was formed. Then came the galactic epochs. So the clusters of atoms formed clouds, and these became the seedlings of galaxies, and stars were born. So the galaxy and the stars were born after the atoms were produced. And they formed all this matter that was there, lots and lots and lots of nucleons and protons and neutrons and electrons. They formed a huge cloud. And because of that, they became like seeds to form different galaxies. And in these different galaxies, stars were being born. So in the atomic epochs, the atoms were born. In the galactic epochs, the galaxies and the stars were born. And now we come to the stellar epochs, which is 3 billion years after the Big Bang. 3 billion years after the Big Bang, the stellar epochs began, and it is yet developing. So we are at present in the stellar epochs. We are yet in the stellar epochs. Time is 3 billions after the Big Bang. The current development of the universe began in this epoch, and formation of stars formed a ripple effect and helped to shape the universe as we know it. So the Big Bang theory is now explained in short as follows. Let us quickly revise what happened. Due to the cosmological studies and cosmology, we came to know that there were three different types: Earth-centric, Sun-centric, and the Big Bang. And the Big Bang is what we are learning about today. So how was the universe formed? Universe was formed during the Big Bang. How did this Big Bang begin? It began with a very, very, very tiny singularity, which was proposed by a Jesuit priest, and the God particle was formed. So after the Big Bang, that is 10 raised to minus 43 seconds, up to 100 seconds after the Big Bang, the whole radiation era stopped. The 4 different types of forces came into play on their own, and then began the matter era, where matter was born. Now this matter has again 3 epochs. The atomic, where the electrons actually went to the nucleons and they formed atoms. And then came the next galactic, where the whole cloud of these matter became the seedlings of our present galaxies, and the stars were born during that time. The sun was born during that time. And then came the last epochs in matter era. We are yet in the matter era. So it is 3 billion years after the Big Bang that the stellar epochs began and the universe developed. And this ripple effect is what we see as the shape of the universe. Okay, so let's move forward. Stellar epochs, heat within the stars help the conversion of helium and hydrogen to form all the elements of nature today. These elements became the building blocks of planets, moon, and life of you and me. We all know we are made up of thousands and millions of cells in our body, animal cells. And these animal cells have millions and trillions of atoms in the form of potassium, sulfur. We have RBCs, we have WBCs, we have chromosomes, we have DNA, what not. So where did we begin our life? We began our life with the Big Bang. And these elements which are now present in the universe are the building blocks of us. Not only the planets and moon, but also us, that is life, our life. All animals, plants present on this earth. Okay, now we say open universe because it is expanding. Galaxies will continue racing outward, and therefore the universe will continue to expand until all stars die off. We all know that in the Vedas and the Upanishads, a lot is written about the universe also. So many thousands of years ago, the sages in India knew about Brahmanda. We call it Brahmanda. So it is an open universe. And now we know that these are the theories which prove that galaxies are expanding, moving away from each other. So the universe is expanding. Of course, we on the earth don't feel the expansion because for us, it is a very, very, very slow expansion. But if you talk about the universe, the galaxies are continuously racing outwards. So, how do we come to the end of the universe? Where does it end? Is there any end for the universe? I don't think so. An open universe leads to total emptiness. Don't you agree? It is an open universe. So what is there now? Total emptiness. There is nothing. So we now go to the saddle-shaped universe. You can see the galaxies are moving away from each other. And this is called the saddle-shaped galaxies. Okay? And it is expanding and expanding and expanding. Now what will happen? The expansion of the universe will finally come to a halt. So the open universe will now become a closed universe. So are we expecting that? So the open universe, which is moving further and further and further away, will come to a time when it will be finally closed and it will say, "Arre, hum to thak gaye. We are very tired. Now we want to close." So the expansion will finally come to a halt. And that will then become the closed universe. So gravity will pull the galaxies back towards the center of the universe again. So now we are at an expanding stage. Don't worry. You have billions of years to live on this earth. Maybe you will go to Mars. Maybe you may also go to Neptune. But ultimately, the whole gravity is going to pull all galaxies again towards the center of the universe. Matter and energy will come closer and closer. And then another big bang will occur. So matter and energy will come close and a big bang will occur and it will become sphere shaped. What was a spindle shaped will become a closed universe. It will become a sphere shaped now. And our book states that the universe is a closed universe. They believe that a big bang may occur once every 80 to 100 billion years. So we know that the formation of universe is a cyclic process. It is born, it collapses, it is reborn, it collapses, and this goes on. And I think we all know that in our Indian system, we say four yuga, and we are in the Kali Yuga. And this will be after some years or after billions of years, the Kali Yuga will end. And again, the Yuga, the universe will begin again. So this is what Big Bang Theory was explained. You can say a lot of probes happened, a lot of missions, and we know that the Big Bang Theory till now, till today, stands true. Now, we don't know how many of you are going to be smart enough and say, I am going to challenge this theory and I will say some other theory. Go on. The world is yours, the universe is yours. Now, what is the contradiction for this theory? There is too much of energy. Most of the universe is an empty space, a vacuum which is defined as a volume containing no particles, force fields, nor waves. By definition, a vacuum has no energy. However, the Big Bang Theory requires both in its early phases and its later phases that the vacuum must have some energy. The law of conservation of energy demands that energy cannot be created nor can it be destroyed. So this is a little contradiction to the Big Bang Theory. So put on your thinking hats if you have and start thinking. Yes, we say there is empty space, there is a vacuum. And if there is a vacuum, particles, waves, force fields should not be there. And by definition, a vacuum should not have energy. But if you venture out into the space, God knows what will happen. So there is energy there. However, the Big Bang Theory requires that it has some energy. And the law of conservation of energy says energy cannot be destroyed, it cannot be created. This was the first contradiction that came to the mind of people. Second contradiction, too complex, too early. Oh my, what does this mean? The universe has too many large structures to be created in 10 to 20 billion years. We know the rate of expansion. Thus, we can get a rough estimate on how long it would take for them to form. In order for these to form, it would take about 100 billion years. And we are saying 13 billion years ago. So the universe has too many large structures. So it is too complex and it is too early. So this is the second contradiction about the Big Bang Theory. Now, summing it up in the form of a graph, the unknown during the first 10, I am revising this a little bit. During the first 10 raised to minus 43 seconds after the Big Bang, we have no theories because the known laws of physics did not apply. In the beginning, the universe most likely had infinite mass density and zero space-time curvature. Size of the universe by the time 10 raised to minus 43 was probably less than 10 raised to minus 52 meters. The four fundamental forces of strong, electromagnetic, weak forces, and gravity were all unified into one force. Now this is, just a minute. This is the graph. So you can see on the x-axis, this is time. 10 raised to minus 43, 10 raised to minus 33, 23, 13, 3, 10 raised to 7, 10 raised to 17, that is today. And temperature from 10 raised to 40, 30, 22, it is 10 raised to only minus 2. So theory of everything. So if you see, this is the graph going up straight, gravity separates, then strong forces separate, then electromagnetic and weak interactions separate. Then we see hot electron quark soup is there, that is the epochs. Quarks combine to form neutrons, formation of the nuclei, then stars and galaxies, and then the universe becomes a transparent radiation. Then the Big Bang again says gravity separates first, then quark electron soup, that is during 10 raised to minus 35 to minus 13, strong forces had separated. Neutrons and protons were formed. Electromagnetic and weak forces also separated, and deuterons formed. And during 10 raised to minus 3 to 3 minutes, the universe had cooled to 10 raised to 9 Kelvin. This was the beginning of nucleosynthesis. And the universe had the size of 10 raised to 10 meters. Then came the light nuclei form, 3 minutes to 300,000 years. Helium and other light atomic nuclei formed by nucleosynthesis. The temperature cooled to 10 raised to 4 and expanded to the size of 10 raised to 21 meters. The universe consisted primarily of photons, protons, helium nuclei, and electrons. Asus, I'm not going to give you the control of my screen, so please stop asking. Now we have the matter-dominated universe. During 300,000 to the present, the universe had finally cooled enough that electromagnetic radiation decoupled from matter. At about 3000 Kelvin, the temperature was low enough that protons could combine with electrons to form hydrogen. Photons could then pass freely through the universe. This continues today as the redshifted 3K microwave background. So the birth of stars, as the universe cooled, gravitational forces attracted the matter into gaseous clouds, which formed the bases of stars. This process continued as the interior temperature and density of these clouds increased. And nuclear fusion began when the temperature reached 10 raised to 7. Initially, fusion created helium from the hydrogen nuclei, and further processes created carbon and heavier elements up to iron. Now food for thought for all of you. Ex nihilo is a Latin term that translated means out of nothing. This was an idea presented by Saint Augustine that became the church doctrine. It is his philosophical explanation of how God created everything out of nothing, which interestingly enough can be applied to the Big Bang as well. Where did everything contained in the Big Bang come from? And why did Big Bang in the first place take place? Why did it bang? This is the food for thought. All those who are listening for the past almost 1.5 hours, this is food for your thought. Start thinking, put on your thinking hats. And a big thank you to all who listened so carefully, so minutely without choking. So now we know how we were born, how we came into the world, how we have existed. Now there are so many hands that have gone up. Mr. Santosh, Atharva, anyone is here? If there is no gravity,
Yes,
so if we go outside, how we don't have no control on our body? Okay. I think Atharva and Santosh, if we can jot down all these from the chat box, and then
yes,
we will see that we can answer these one by one. All cannot be answered. So for the next session, we will have all these answers ready. I think that the energy is zero. Oh my God. Can you please explain, ma'am, what is it? There is no gravity. Going on and on and on. Really smart children we have here, Santosh. So many questions they have. All these questions I'm going to give to the ISRO scientists now. Okay? I am not an expert in cosmology. So I will have your questions to the ex-ISRO scientists who are actually cosmologists who can tell you a lot of things. So anything that you can answer, Santosh, because there are too many chats and I can't.
Ma'am, the students are continuously keep on asking questions. So what I have done, इसको कॉपी कर लेते हैं सभी और जॉट डाउन करके फिर एक सेशन इनके क्वेश्चंस के ऊपर रखेंगे नेक्स्ट वीक में, जैसे
Yes, because
कोशिश करने का.
absolutely, because understand, when I was small, that was 50, 60 years ago, I used to keep asking my mother so many questions about the universe. And at that time, Google Baba was not there. There was no internet. We didn't have even TV at that time. So now I know in your mind you have so many questions. So we will answer each and every question. Dark energy and dark matter, we are going to have a session on that. So the next session that I'm going to have, 4 lectures we are going to have. So one lecture will be on the black hole. Another lecture will be on the dark energy and dark matter. The 4th lecture will be on galaxies. So these are 4 lectures that you are going to have. I have given you the dates. It will be 6th March was today. Then the next week, it is going to be 13th March. Then since many of you will be having examinations, we will then begin on 10th of April. And I think then it is 17th of April. So 4 lectures where you will learn a lot about dark matter, dark energy, and also you will understand what is a black hole and also what is a galaxy. And then we will go for the satellites. You have exams till 23rd April, my dear. Okay. But on a Sunday, on a Saturday, half an hour, 1 hour, you can sit. Isn't it? Quantum mechanics says that a vacuum has energy. Okay. So children, lovely questions that you have put in. We are all going to take it down. There are about 5-10 minutes left. And how did you find it? If one of you can unmute and say, Gitika ma'am is there? Gitika ma'am?
Yes, Gitika ma'am is there.
Okay. Anyone who wants to say, what did you learn today and did you understand what is the Big Bang Theory? We talked so much about the Big Bang Theory, but now you have all understood the 2 eras. Ma'am, I want to ask, okay. Gitika Berry says something. Lithium, beryllium, these are also elements in nature. Why can't we see if Big Bang is happening, going to happen again and again? It is going to happen. And that is also Indian, if you look into the Indian system and what the rishis and Mahamunis have said, we all believe in the 4 yugas. So the last yuga is going on, that is the stellar yuga, stellar epochs, in which we are expanding and there will be a time when it will stop. And then next, we are going to learn about what is a black hole, dark energy, and dark matter. Okay. 10 raised to minus 43, the time. That means when the Big Bang happened, 10 raised to 43 seconds had elapsed. Now, do you understand how small it was? Because in 100 seconds, that means in, you can say 1.5 minutes, The matter era had begun. So the concept of time, and that is what Einstein has said, that if you can travel with the speed of light, time for you will stop. This is a little difficult to understand. 10 raised to minus 43 seconds is very, very, very.
Ma'am.
If the universe is accelerating, how will gravity stop it? Yes, a time will come. See, we all know that there is a limit to everything, isn't it? So there will be a limit to the expansion of the universe also. So when it comes to its fullest, gravity will say, चलो भैया बहुत हो गया, बहुत मस्ती कर ली, बहुत expand हो लिए, अभी चलो वापस. Get into one small singularity, and again a big bang will happen. Okay, so thank you, children. All your chats have been saved. Santosh?
Yes, ma'am. I'm
All the
just
chat-
copying
Huh?
all the questions, and dear students, you will get all the answers. Don't worry.
There are more than 100 questions, I think so.
We have one session with the scientists. Don't worry.
The scientists are also going to speak to you. So there is a question who says, is there a Big Bang happening somewhere? Oh my, this is a question worth thinking on. So there's a question which has come on the chat saying, is the Big Bang theory, is a Big Bang happening somewhere? Yet we are not reaching the moon. So where will we reach that another Big Bang? It will take us, I don't know, years and years. So thank you, students. Thank you for being such a wonderful audience. And we'll wait for the next Saturday where we'll have one more session. And after that, after your exams are over, we will have another session. And from the 8th of May, your sessions for the ISRO program will begin. That is the Bhavishika program. So you will have lectures online only. At least for this year, we are going to have online lectures. Okay? So all of you can leave so that we can copy all the chats properly. Santosh, I don't want you to miss out even one question.
Yes, ma'am. I'm trying to copy. Just as soon as the students will leave the classes, then we'll copy all the questions.
Yes. So children, I would ask you to leave and have a nice weekend and keep your thinking hats on. And I have told you that there is food for thought for you. So start thinking. And let us see these wonderful children once again on next Saturday. Okay? So I ask every one of you to leave so that all the chats can be copied down. Bye, all of you. Good night. Have sweet dreams about the Big Bang. And study well for the exams. Your exams are drawing closer. Goodbye and a happy weekend to all of you.
Bye, all students. See you
The
next Saturday.
room, yes. Please leave the room so that we copy down all the chats. We require all the questions to copy. Okay. Aditya, Utkarsh, leave so that we copy the chats. Mahir, Ruchit, Ashni, Omkar, leave the room. Arush, good, good. Hello, हाँ बोला.
Students, please leave the class.
ओके संतोष सगळं झालंय कॉपी करून गीतिका how much did you understand
Yes, ma'am. One moment.
how did singularity form oh my god Jins Johnson is asking yes singularity God formed it that is the
Ma'am,
God particle yes
can we leave the meeting and then we can have again discussion?
okay fine
I have
So-
just copied all the questions.
okay
Okay, ma'am.
okay so I'll okay she can't unmute I will talk to you Gitika so I'm ending the meeting now so we can have all the questions and then all answers can be given so
Yes, ma'am.
goodbye
I have
all of
copied
you
all the questions.
bye though
Okay.
bye bye good night